So I'm going to quickly discuss the questions from chapter 2 quiz, and it is going to be useful for you to see where you went wrong in case you went wrong, so that you can prepare better for the next test that is going to test you on the same concepts seen in chapter 2. So the first question is about naming the structure. So the rule for naming a cyclic structure is you want to identify how long or how many carbons the cyclic structure has, and then you have to give the locant to the most appropriate side group. So this could be a position that you can start numbering the cyclic structure with, or that could be the chain. So these are both equally viable as beginning points, but of course it's a tie. Therefore you have to break the tie in favor of the alphabetical ordering here. So bromine has to be 1, and you cannot go counterclockwise. You have to go clockwise here, because that way you can do the smallest number here. So this is going to be 3. So 1, 2, 3, and therefore this is a cyclopentane, and it's 1 bromo and then hyphen. Now you have a 4 carbon chain, so a 1, 2, 3, 4, and that is a secondary butyl. So this is going to be a 3 sec butyl cyclopentane. So that is going to be the name of the structure. That is going to be 1 bromo 3 secondary butyl cyclopentane. So this is a concept that, as I have mentioned in this problem here, that I have discussed in the classroom. So when a molecule is very unstable, say for example you have two molecules, molecule A is here, molecule B is here, and they end up both giving the same product. Let's say for a product of combustion, it's going to be CO2 plus H2O. And the more unstable molecule, which has a higher energy, is the one that is going to give the most amount of energy out. So if you have, say for example, cyclopropane and let's say methyl cyclopropane, for example, and cyclobutane, they both have the same molecular formula. This one is more unstable because it has a lot of strain energy in the ring. Therefore when you burn this is going to release the most amount of energy. So that's basically what this problem tests you on as well. So the problem gives you the background that the more unstable a molecule is, the more heat it releases upon combustion. So we have to find out which among these molecules is going to give you the most amount of heat upon combustion. So hexane is a straight chain compound, and we have to consider that cyclohexane is going to have slightly more energy, which means it's slightly more unstable than a hexane itself. Then you have 1,2-dimethyl cyclobutane, 1,2-dimethyl cyclobutane, 1,2,3-trimethyl cyclopropane. So they all are molecules which contain 6 carbon and approximately the same. This one has 2 more hydrogens, but all the other structures we have here, they all have the same number of hydrogens. So they're all isomers of each other. This one is almost an isomer, so it would not make a huge difference with regards to the change in molecular weight, because it has 2 hydrogen in being able to answer this question. So 1,2,3-trimethyl cyclopropane is here, and then methyl cyclopentane is this, and 1,2-dimethyl cyclobutane, or 1,1-dimethyl cyclobutane, is an isomer of this molecule. So 1,1 is here. So between these molecules, this is going to be the one that is going to be the most unstable, which means that is the one that has the highest amount of energy, because it has the greatest amount of strain in the cyclopropane ring. And therefore when you burn this, it will release the most amount of energy, whereas other ones which are more stable are going to release less energy, because finally they all end up giving the same product. Okay, so the answer to this is 1,2,3-trimethyl cyclopropane. So this problem is based on one of the problems we have seen in the book, where you are given a wrong name and you're asked to give the right name for that structure. So 4-methyl 6-isopropyl heptane. So first draw the heptane, 3, 4, 5, 6, 7, and then 4-methyl. So this is 1, 2, 3, 4, 4-methyl, and then 6-isopropyl, 4, 5, 6. 6-isopropyl. That is the name. So the wrong name is based on giving wrong locants and also identifying the wrong longest chain, because if you have this structure, then the longest chain is going to be that involves this carbon. So 1, 2, 3, 4, 5, 6, 7, 8. That will be the structure that I would want to go with because it has the most number of branching out as well as the longest chain. Alright. So now based on this, there is a methyl on the second position, on the third position, and the fifth position. So this is going to be a 2, 3, 5 trimethyl octane. So that is going to be the name of that compound. And this problem asks you to give a name for the molecule based on its Newman projection. So for these kind of questions, you would want to translate your Newman projection into the straight chain wedge and broken wedge notation. So there is a carbon here in the front, that is the circle here, and there's a carbon right behind it. So you want to draw the two carbon bond, and on the front carbon, let's say you are looking at it from this angle here to your right, there is a CH3, which means that CH3 is to the right. And make sure you use models to really understand how I'm translating this. Alright, make a model, change its point of view and change your vantage point to keep this carbon in the front, and that way you will be able to see that you have a CH3 on the right, and then you have a hydrogen on the left, a hydrogen coming here on the bottom, and then on the carbon behind you have a bromine. This is a staggered conformation, so the bromine is here, and then to your right, if you're looking at it from this angle, this is the carbon in the front, this is the way you're looking at the carbon in the front, and to the bottom on the right hand side you have your isopropyl, and then on the left going down you have a hydrogen. So now this is the molecule, and now you should be able to name this molecule. So if you go from this carbon, so this is 1, 2, 3, 4, 5, it's a 5 carbon chain, and the first substituent you get is on the third carbon. Whereas if you go from this end, this is going to be 1, sorry, let me use a different color. So this is 1, 2, 3, 4, 5 as well, except here when you go from this side, you get the first substituent on the second carbon. Therefore this is the right way to go, and therefore it's going to be a pentane, and then it's going to be 3-bromo hyphen 2-methyl hyphen methyl pentane. Alright, so it's going to be 3-bromo 2-methyl pentane. That is the name of that molecule. And here we are looking at matching the names. So C7H14 is a straight chain compound. So C7H14, 2, 3, 4, 5, 6, 7. Ethanol is going to be the CH3, CH2OH. Cyclopropane is that. Cyclopropane again is that. 1,2-dimethyl cyclohexane is that. And the Gaussian anti-interactions are, when you have a Newman projection, they are both staggered conformations, and when you have a staggered conformation like that, and you have the bulky groups on the exact opposite sides, they are called as the anti-conformation. And when you have your bulky groups in staggered but still not far away, they are still close to each other, that is called as a Gauss conformation. That's a Gauss conformation. Alright, so let's see what options we have in the drop down list. So C7H14 is among these compounds here is the compound with the highest boiling point because it's the largest compound. It has the most amount of surface area. Ethanol, obviously only structured here with with hydrogen bonding. Cyclopropane, you can have a molecule with the highest energy, and cyclopropane also is going to be a molecule with 60-degree bond angle. They both apply to this because this one will not have a 60 degree, it's going to be close to 109. And 1,2-dimethyl cyclohexane is a molecule that can have cis and trans isomer, because you can have two methyl groups on the same side, which is cis, or you can have the two methyl groups on the opposite side, like that. No other molecule can have that kind of geometric isomerism. And Gaussian anti are therefore going to be the only option left, which is or different staggered conformations. Alright, so that is what you want to know about this. And so we have discussed in the classroom that having bulky substituents such as methyl in the axial position destabilizes the conformation due to the 1,3 interaction. The three structures below arranged in order of decreasing stability. So you want to go from the most stable to the least stable. So when you have a bulky group in the axial position, that is not going to be stable. So between these three structures, these two methyls are both in equatorial position, because that is the axial position here, right? Therefore C is going to be the most stable, followed by one in axial, the other one in equatorial. So B is going to be the next more stable structure, and A is going to be extremely unstable because both of them are in axial position. And the reason why it is going to be unstable is because there is going to be the 1,3 interaction between the two bulky methyl groups, as well as the hydrogen here and the methyl group here. Whereas in this case, there is going to be only one bulky group in the 1,3 interaction, and that bulky group is going to have two small hydrogens, as opposed to this where two large methyl groups are interacting. So you're replacing essentially a small hydrogen with a large methyl. That makes it very unstable. Therefore A is going to be the least stable structure or conformation of this molecule, and therefore it's going to be CBA. That is the answer for that. So hope this helped, and make sure you keep track of where you went wrong so that you can avoid those mistakes in the test next week.